Hello and welcome to this video from Medihead Bridge. In this video we're going to see how to deploy the Cloud Security Connector PriCPA with Outbound Firewall or Advanced NAT Gateway on Google Cloud. Here is the infrastructure we're going to build. The first thing we need to understand is that on Google Cloud, when you have a virtual machine with multiple interfaces, each interface must belong to a different VPC. Don't ask me why, but it is what it is. Then to deploy, the Cloud Security Connector has three interfaces. One is the internal interface, the other one is the interface for services, when the connector connects to the Google API or goes to download the policies. And also we have the PriCPA and firewall interface. So this is the real interface where the traffic goes to the other site or it goes to the internet for the NAT gateway. We have a worldwide network here, and we are going to integrate a connector in Google Cloud to our worldwide network. Have different places: United States, Europe, Japan, Australia, and South America. Then the first thing we need, well, we are going to build this connector. We are going to build also a bastion host. This is for purpose of demonstration, and an internal machine, and Ubuntu server. One very important thing here is that Google Cloud recently decided to move away from the Google Deployment Manager. That was the system to deploy resources in Google Cloud, and they moved to Terraform. And what is Terraform? Terraform is a declarative language or something like that, where you can create infrastructure as a code. And what the Terraform does is you define all your resources you want to create, the VPC, a subnet, an instance, all the things you can create, very interesting logics. Also, Terraform, after you deploy, it keeps the state of the things. Then it's a very valuable tool, and it's very wise to use Terraform. And but at the end, in the logic of the flow, how it works, Terraform will do commands using Google CLI, and Google CLI will execute the commands in the cloud. Then we create templates here. When we execute the template, it will go to Google CLI, and Google CLI will execute the resources in our cloud. This is very important to understand. And then what we need to have installed on our machine is Terraform. If you put install Terraform, you can install for Mac, Windows, or Linux. And also we need Google CLI. Then our requirement for starting deployments is to have Terraform and Google CLI. Well, I have a project here. It's called Medihead Bridge Demo, but the project ID is this one. Important. Remember, the project ID is not the same than the name. It can be the same, but it can be different. Then here is my project name. I have nothing created, and I'm going to create the resources. When you are using Terraform, one important thing is directories, the structure of directories you create. You can go to Terraform and to study the different ways to create directories. I have one directory per cloud. In the case of Google Cloud, I have my project, and inside my project, I created compute and networking. What I'm doing here is similar to this. You have networking here, and you have cloud compute engine. Then I'm emulating this on my directories. You can do different if you want. You can use your own strategy. Then the first thing we are going to create is the networking, the VPCs and subnets. And to edit Terraform files, please ignore this one file and these two. The template is this, and this. The software I recommend to use to manipulate this file is to use Visual Code. Another software, download Visual Studio Code. You can download for Windows, Debs, and Mac. And the other thing you need to do as soon as you install the Visual Code is to add some extensions. The extension will help you to correct your code and to beautify and to make it better. Then at least you need to have this extension, the HashiCorp Terraform, but I recommend to use, if you are multi-cloud, Azure Resource Manager, CloudFormation, and if you're using Bash templates, it's Beautify Bash or shell format. Then I recommend to have these extensions, and I have here on Terraform now, this is the directories, and I will work on networking. On networking, we have, in general, you need to define the main, the variables. It's the two files you need to have on Terraform. I created this is for you. This will create, then you don't need to be worried about variables and the main. And all this information will be available on support. If you type support.mediahillbridge.com, you will get our knowledge base. You can click documentation, and we will put all Terraform templates and videos here when I finish this video. Okay. Then going back, the main template here says a lot of things, but it's going to create VPCs and subnets, and you don't need to touch anything here. But on TF-var, Terraform variables, here is where you need to put your values. And you need to put your project ID. This is my project ID, the region you want to deploy the VPCs, VPC name, subnet name, and the IP and subnet for the IP and for the subnet. Then I have 3 VPCs, and each VPC 103, 0, 10, and 20. 2 externals, 1 internal. The only difference between VPCs is this one. Okay, the externals one will create by default a default route to the internet to get access to the internet. Then you don't need to create nothing else for the externals. And the internal, what we are doing is we say it's private, then don't create anything, no routes, default route for that particular VPC. The installation is extremely simple. Then come here, I will open a terminal, and I will do Terraform init. It's already initialized because I did a test. Okay, looks good. Terraform plan. It showed me all the resources that's going to create. These 3 VPCs, then Terraform apply. Do you want to do all of this? Yes. We need to wait a little bit and Google CLI. Okay. 2 of them are created now. Create the subnets. Okay, and here is showing me the VPCs and the routes. Let's take a look of the output. If I do refresh now, I have these VPCs. If I go to this one, you will see that the subnet and the route created. I need to put the region. Europe and London. Okay, it has the default route to the internet. If I go to the internal one, I don't want this to have exit to the internet. Then if I go to routes in London region or whatever, it's only local communication and not default route to the internet. Well, first step is done. We have now VPC internal, VPC services, VPC PriCPA. We're going now to create the bastion host to get access to the CSC. For the bastion host, I need to know my source IP, HTTP, because I'm going to ip.mailbridge.com. This is my source IP. Okay, going back to the Terraform, to the directory GCP, I will go to the instance now, and I'm going to create the bastion host. For the bastion host, also we created your main, your output, your variables. You don't need to touch any of this. And on the Terraform TF variables, you need to put your values. In my case, this is my project ID, this is my region, this is the name of the instance, this is the VPC, the internal, and this is my public IP now. Okay. And the key. Also, I create keys. I put the key here on the public key and the user. Okay. Then now I will go to the compute instances, bastion host, and I'll open terminal here, and I will do Terraform init, Terraform plan. Okay, chmod, sorry, this is a backup. Okay. It's the same. Copy. Okay. P6. You can ignore this. This is because I'm doing several backups through my account. Let me back. Paste. Okay. Okay, I do the Terraform plan, everything looks good, and now I will do Terraform apply. Do you want to apply? Yes. And now it's created the bastion host. What we are creating now is this device. And on the bastion host, what I'm doing is to create from my source IP, I will allow access to the bastion host. And also the bastion host has a route going back to the internet for my IP. Then only people from my IP will be able to get access to this bastion host. And in return, I have the IP of the bastion host. Okay. Now I will use this software called Remina, Remote Desktop Client, to access to my bastion host. I will change this IP. I'm using an identity file, bastion key is by, and save and connect. If the bastion is up, it will answer. Okay, then as you see, Terraform is very nice. It's very good, and what it was created now. If I go to compute engine now, sorry, compute, come on, compute engine, virtual machines. I have this bastion home instance with this one, and I'm able to SSH the instance. The next I need to create is the Ubuntu server. This is an internal machine to do testing. Then it is here on this. I need to place on this subnet, and that's it for the moment. Then going back to my directories here, compute instances, I have the Ubuntu server. Okay. Again, the main output, blah 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 blah. You don't need to touch. You need to touch this Terraform tf bar file. If I show you the variables here, again for this Ubuntu server, I need to put my project ID, the region, the name, the zone, the VPC. I put an internal, the public key for this device, and the user. Okay, I'm using SSH keys for everything. Well, Google use SSH key for everything. Then I will get into this directory, and I will do again Terraform init. Okay, if I do Terraform plan, probably again the permissions will say chmod plus x. This version. Okay. Now Terraform plan and Terraform apply. Done. What it's doing here is the instance and the resources and the routes and the values, right? And this is the instance IP. Then as soon the instance wake up, I will come with my software to go to Ubuntu server. This is the private IP, and for the moment I will leave as is. I will log in when the PriCPA is. I will save, but I will not do anything else. Okay. The next I need to do is to install the PriCPA now. I do the installation of this. Now I need to do the PriCPA. If I check the instance here, I have the bastion and the Ubuntu server. Okay. Very good. Let's, as I said, we are in compute instance PriCPA node, and I have here the PriCPA demonstration. I create this directory. And how to create the PriCPA? Well, you need to go to, if you type here Maidenhead Bridge, you will have the connector for Zscaler here and this one, close to PriCPA. And as soon as you click launch, it will ask first for the license if your first time, and you can almost ignore all of this, but here download the zip file, the Terraform zip file. Okay, and I did this already, and on this directory I put a template. This is my zip file, and the zip file contains all these values. Again, you don't need to be worried main output variables. You need to take a look of this too. This one, the TF bars, is for the variables we need to input to create the connector. And this configure user data is some parameters we can pass to the connector at the moment of the deployment to do it more automated. Then let's take a look of the values. Then PriCPA node, and as I said, main output blah 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 is all already created. You don't need to touch this, but you need to take a look of these two files. The first file, the TF bars, you need to put the project ID, the name for the PriCPA, the region, zone, the machine type. We recommend to start with this E2 high CPU 4. You need to create the SSH key. On the SSH key, paste here your public key. One unimportant thing, at the end, you need to have the word CSC admin, the username. Then when created the SSH key for the connector, use this command. Or if you are using a key already created, simply go to the end and delete any command on the key and put the name CSC admin. The reason of this is because Google Cloud requests you to the username is the comment on the key. This is the way the Google Cloud works. Then remember, if you are going to create a key for the connector, use SSH key generation minus comment CSC admin. And finally, you need to assign the VPC and subnets for the instance, the services, the internal and external, Ethernet 0, Ethernet 1, Ethernet 2. And I have the names here. But that's all I need to do. In the config user data JSON, this is values parameterization for the connector. And let's start with DNS. You can put your own DNS here. If you have a syslog, you want the connector send the logs, system logs, to a syslog server. You need to put the IP and port. If you want the connector to send traffic logs, traffic allow, block via PriCPA, via outbound firewall, you need to put it here. The next is the advanced net gateway, the outbound firewall functionality. The best way to work with the connector is to use a JSON file with the rules. Okay, I have here, this is the JSON file with my rules, and in this particular case, I'm going to say anything on the internal interface going to any IP port 8443 TCP allowed to go, then, and also DNS and an NTP. Then what I'm saying is this instance can go to DNS and web traffic. But you can be more restrictive. You can create policies with more restrictive values. In particular, saying for source and destination. For example, I have a rule here saying any machine on my network can go to the Ubuntu repositories. Allow, it depends on the site, you can say the source and destination. And finally, for my entire organization, I have a rule for the Office 365 endpoint. allowing any in my organization to reach Office 365. This is very short set of rules, but this is public destinations that the connector allows you, remember, to allow internet communications, but also when this device need to go to the internet, for example, going to Ubuntu repositories, they can go directly. Then the connector replaces the VPN gateways, and also the NAT gateways on a cloud environment. And finally, there is one thing on the config user data that I added here, and it's the PriCPA values. Of course, I will enable PriCPA on this connector, the name of the node, the location, the public port, UDP port I want to use, the private IP of the connector. When you design in Google Cloud here, when you design a PriCPA network, each PriCPA network has its own IP, and each node has its own subnet, and each node has its own IP. Then on the node, I need to specify the IP of the node. Then this PriCPA IP is the private IP of the PriCPA network. PR JSON file, what is all? It is the JSON file of all connectors. Remember, this is the file we distribute across all devices, all PriCPA devices, and the PriCPA devices reading this file are able to create the full mesh cloud and the zero trust environment. In this example, because it's a multi-cloud network, I'm using a bucket on Amazon, but you can use a bucket on Google Cloud or whatever you want. Remote management networks. This is another important parameter. When you want to, by default, you can get access to the connector via Ethernet 1 here. But if you have your management network from here, and you want to get access to this device, you need to specify the subnets, your management networks. Then management networks are defined when you are not getting access via Ethernet 1, when you need to get access via remote to the connector. Then these three are my management networks. SSH restrictions, you can apply restrictions to the connector to say I will be able to log in only from these locations. And also you can enable admin console, access to the Linux console on the connector using the CSC CLI. The other thing I want to mention this file is the AWS SCCM agent. You can manage the connectors, you can deploy the connector using Terraform, but you can manage the connector with any change management and monitoring tool. It can be Rundeck, Ansible, AWS System Manager, or SSH, any tool. I decided to use System Manager. The connector comes with the client already installed on the connector because it's a lovely management. If you're not familiar with System Manager, it's it's a tool that AWS offer for free. Then you don't need to pay anything for this, up to 1,000 nodes, and it works very well. It's very light, agent, and will allow you remote access to the device from the cloud. I have my entire cloud here. Say pin status equal online. I have 22 nodes. Okay, and what we are going to achieve putting these values of activation and this, because you need to create something called hybrid activation, and to to register the node. I created a hybrid activation before. Then as soon the connector starts, the connector will go to register to the AWS, and you will be able to manage remotely. Okay. If you're familiar with AWS, honestly, you don't need to create a bastion host. You can directly manage from the cloud. I offer both in this particular case. Okay, we have everything we need now. We have the template for the CSC PriCPA. We have the variables file with all the data, and we have the config user data to automatically create most of our setup. Very good. Let's shoot this. Then I will come here. I will open in terminal. I will do Terraform init. You will blame me about Terraform plan. In this case, I need to specify. Okay, let's take a look of the README file. README file. Okay, in the way to deploy this in particular, because this CSC Terraform auto bars, we need to do this command Terraform plan and to specify the variable files. The reason of this is because we changed the name here, but this is intentional. Then I will do Terraform plan auto bars. They will blame me. A permission to this version. Let me do enable permission to this version. And now let's do it. And here is all things that plenty of things that this template will create: firewall rules, the instance, firewall rules, interfaces. Well, a lot of things will be created via this template, and now let's apply it. Yes. Everything is automated. The template is creating all these firewall rules needed, all the interfaces, everything is automatically created. You don't need to be worried about. We did a template in advance for you. Okay, and now I have the public IPs, the private IPs. The first thing I need to pick up is this public IP of the services interface, because on my bucket here where I have the two JSON files with the NAT gateway information and the private CPA, I have a permission and the policy is per source IP. Then I will edit this bucket. I will add the service IP, because the queries to the bucket will come from the services IP, from this IP. Okay. Then I have the IP information and also the internal information. This is the IP of the connector. Then coming with my SSH software, then to access to the connector via the bastion host, I need to put the private IP, and it will be via this 34.147. This is the IP of the bastion host, 178.2.14. Okay. If I do, I need to wait because the connector is starting, then it's rebooting once. It's doing a lot of things. But if I do save and connect, okay, I am in the connector. When I did this from my PC using this bastion as a sham host, I have access to the connector. And the first thing the connector is asking me is okay, the connector did a reboot. Okay, let's wait a little bit. So after, when you use config user data, when you use config user data JSON, the connector boot twice. It does in the first start and then it boots again. Then I need to wait a little bit. Meanwhile, I will edit this communication. This will be 24. Save. And let's connect via the bastion again. Still loading. Okay, wait. I need to wait a little bit more. Still loading. Okay, we can check, for example, if the node, well, I have 23 now. Then the PriCPA GCP demo is here. PriCPA demo. Then, as you can see, the node via the parameter we sent via the SMA agent automatically is registered on my AWS console. For management purpose, the node settings, I will add tags, and I will add PriCPA tag. PriCPA submit. And let's check. Let's check the tags. PriCPA. Very good. Let's go back to the connector. Probably is via PriCPA via bastion. Okay. The first the connector is asking me is if did you add this node to the PR.json file? PR.json file. What is the PR.json file? The PR.json file is the file where we put the values of the node, the networks behind, and the private apps for the zero trust. Remember, when designing a PriCPA, you need to know the public IP is created automatically in the cloud. We need to know the private IP of the node we send via the config user data JSON file. And also we need to define the subnets behind the node. And after, this is the three values to create the full mesh, and after you need to define this instance will communicate or will be accessed by other sites. In our case, we need to get, these values are not correct from the previous setup. I need to correct these values. Then my first task is to go to show local configurations and insert the JSON section into the PS.JSON file. Also add the subnets behind and the private apps. Did you did it? I didn't do, but I will put yes. I will go to 14 and I will show me the local configuration. And the local configuration will show the token. This should never be published. This is the private IP and the values of the node. Okay, then I will pick up the node up to these values. Copy. Look at the public IP and the private IP, and I will put on my JSON file here up to here. Okay. Networks behind. The networks behind is this network 10.103.20 behind the connector. Then my network behind is this one. That's okay. And on private apps, I will be very open here. I will say to this destination subnet all protocols from anywhere. Then I'll allow everything. This is no zero trust. This is everything. Then I will click save, and now I will update my bucket. Okay. Remember, the connector is pointing. The connector, we pass to the connector the configuration of this bucket. Okay. Then as soon as we send a command and say to the connector refresh this file, the connector will create all policies and it will join to the PriCPA cloud. Then going back to my bucket here, let's go to the objects, upload, add files, PriCPA, JSON lab, this one. Okay, upload, close. That's it. The next task is I will do manually here. The next task, the local configuration was created automatically during the boot process because we passed this information. And the next task is to upload the peers JSON file. Then go to 2. What do you want to do is to use private URL. Remember, it's already configured. Do you want to change? No. Do you want to refresh? Yes. Do you want to take a look? Do you want to apply these values? Yes. Okay. This is one thing you can apply manually in the node, and the node will do all this work and will add all private apps for this node, creating the zero trust. It will include the other node, and also, very important, it will create all security groups, inbound, outbound, to reach all these nodes. Okay. I'm doing this manually because show you how the process is. Okay. Then now we have PriCPA ready, inbound rules, outbound rules, all the peers with other nodes. But I need to tell all the other nodes in my cloud, all other nodes in my worldwide cloud, that this new connector exists, right? Then what I'm going to do this is via the fleet manager on AWS. Remember, I have all my connectors here. I have 23 nodes now. And the beauty of the fleet manager, it allows you to run commands on the connector. And the connector has something called documents created, where you can execute the specific commands. Then I will run a command owned by me, and I will execute this document, refresh private access PS URL, and on all nodes with tag PriCPA. All my nodes have this tag PriCPA. And I will put array control, I think it's, I put 10 at the same time, or whatever. Then what is happening now? The AWS System Manager is executing a command on each node, on the 23 nodes. Every node is coming to this bucket and is downloading this file that I updated, and is creating the policies and is integrating this new node in the cloud and all the rules for Zero Trust. Then I need to wait a little bit here. Meanwhile, this is an execution. Okay, I have 22 targets here. Well, this is done. The reason why PriCPA demo is done because it was updated. Then this shop compares your previous, and if you have the latest version or not. Then the first one with the latest version was this PriCPA demo because we did manually. And now, meanwhile this is happening, let's do something important here for this Ubuntu server. We need to create a route that say all traffic go via the connector. Then private traffic will go to the other private places, and public traffic will go direct to the internet. But this route we need to do manually. Okay, then let's come here to the VPC network. Okay, and I will create a route for the internal VPC in the region of London, of where I'm working on. Okay, this is the route I have right now. This is not the full route. Then if I go to Route Manager, I will create a route for the VPC. Then default via CSC, internal VPC, static route, destination IP 0.0.0. Next hop, specify IP of the instance, and if I come here to my Terraform, you can see private IP instance of this of the CSC ST10.4. Let's do copy and create. Okay, let's do a refresh. And this is an active route now. Then, if I go to my Ubuntu server now, well, let's wait for the PriCPA to end. See here. Okay, all is complete. Then I should be able, via PriCPA, to go to this Ubuntu server. Lord, I think I don't remember. Okay, it's blaming me for the key. Probably I did something wrong with the key, but easy to solve. On Google, high communications, PriCPA is working. It's great, but I have some problem with the key on this server. Then GCP SSH keys, Ubuntu server key. Let me check here, edit, Ubuntu server key, ta-tan. No. Okay. Let's do something fast to avoid more problems. Then I will come to this terminal. SSH. I don't remember the key. Authentication. Ubuntu server. Ubuntu and no password, please. No password. ls. I'm sorry. Ubuntu Ubuntu.pub. Okay, then let me add this. Okay, you can learn how to manage keys in Google Cloud. That's very smart, by the way. I like that. Open a new tab. I will go to Ubuntu server. I will edit, and on SSH keys I will add an item, this one, and save. Okay, good. I added this SSH key, recently created. If I come to my software now, I will edit here. I will say go to Ubuntu. No password. Not password to unlock. Save and connect. Okay, we are in now. This is we are into the Ubuntu server. And if I do curl ipinfo.io, this is a URL is allowed to go. It says this instance can go into the internet, and the IP, public IP they are leaving is this one 170. Then the NAT gateway is working, it's already working. And the reason it's already working, the NAT gateway, is because we have here on the firewall rules a rule that allows, on the beginning, a rule that allows anything on this subnet TCP. Then the NAT gateway is working. We create a route via the connector. This device can go out, and it's using this IP 170, that is this one. This is the IP of the connector for PriCPA and firewall. Brilliant. Very easy to do. Now, if I, from the Ubuntu server, if I go to an internal place, I don't know, curl 172.99, that's 199, I guess. Let's do HTTP. Okay, yes, I get the internal website. Some HTTP cover. This is the internal website. Manage a bridge, private access, cloud private access work perfect. This is the Ubuntu server is coming here to this data center and to the web server. Then private traffic is working as well. If I do an pin 172 on internals all internal stuff is okay. Then with this simple setup now, this Ubuntu server is capable to go to the internet as advanced net gateway and also to the PriCPA. If you want to check on the connector, now I can reach the connector directly via PriCPA. This communication is not via a tunnel. Then I'm inside. If I do a check, how is this device with the others on the network? Well, we have some of them that are offline, but as you can see now, the PriCPA on Google Cloud is alive with the others connected in the network. Extremely simple to do also, because also we sent, remember, we sent traffic to the Google, we set up the, let me see if I can find PriCPA, we set up the logs. I want to show you the logs for this device, trying to find the name, because we did an update the complete network. We have plenty of logs here. Come on, PriCPA G Cloud somewhere. PriCPA public, guess this one. I'm unable to find the logs now, but okay, there are plenty of them. Let me show you here. If you do one, show configuration status, the PriCPA demo will show you all the information about the external interfaces, internal interfaces, the service IP, PriCPA IP, DNS information, private access, if it's active, outbound firewall, NAT gateway is active, the ACC emission was registered automatically and also is able to reach the syslog. Well, this is the end of the presentation. As you can see, using Terraform is very easy to do. It was very easy to deploy a bastion host, a Ubuntu server, and the connector, and also the subnets. As I said before, if you go to support.medihebridge.com, you will be redirected to this site, and on clicking on Cloud PriCPA here, we will add the information of this video here, and also all Terraform's template to create this VPCs, to create the bastion host, to create an Ubuntu server, and of course to create the CSC, the Cloud Security Connector. Well, I hope you enjoyed this video. As you can see, it's extremely easy to do a worldwide network, any-to-any communication, without creating IPsec tunnels in advance or BGP or routing. You don't need to have any networking knowledge other than private IP. Well, public IP is created automatically. Firewall rules are created automatically. This is the one something you need to manual, and of course to decide which is your subnet addressing, and the connector will do for you all the rules automatically for the worldwide network. And also the connector does the NAT gateway. Then you can put your default route to the connector, and this instance will have access to the internet, for example, for Ubuntu repositories, and also access to any of the other regions, your private clouds and regions of the world. Well, thank you very much for your time. I hope you enjoyed this video. If you have any questions, please don't hesitate to contact us. Log in on the support.medihebridge.com and open a ticket. Thank you very much and have a good day.